Okay, so now we are going to talk about the topic data types that exist in Postgres. Now, as you saw so far, when we have a column, we need to have a very specific data type. That means that only one data type can be assigned to a specific column. And here I just display to you the several categories that Postgres currently has. Now, this is not a complete list, it's more vast, but just to remember, these are not data types, these are categories. And for example, numbers category can contain multiple data types and so on. Now, what I highlighted here, these four, is probably the most common data types that you are going to use and the one that we are going to discuss in the next videos. The other 8, I just put this for reference, just so you know it exists, but it's not so common, and when you will tackle in your next project or next application, just know that there are this type of data types, and you can search them, you can Google them, and you will find how you can assign this. Now, let's talk about numbers data type, this category. And this category can have multiple data types, which is basically a number. Now the most common one is integer that you will typically use, and this is like a data type that you can store between this range. You can see here it's very big range, and you can store basically every number between this minus and this plus. But if you want numbers that are greater than this, and sometimes you will see this probably in your primary key ID, maybe you have a table which has more than these columns. It is too big for me to pronounce, probably it's 2 billion or something like that. You can use big int, and this big int is basically the largest integer, and you can see here it's very large, and you can basically contain every number that you will basically use. Now, small int is just a small number, and you probably you won't use it, only if you will use something like a database in the cloud services, and the storage is on money and on price, and you need fewer memory. But don't worry about it. So you have small int, integer, big int. Now the next three, it's basically the same as this, but it just has an option or a feature that will auto increment, and we will discuss this when we'll talk about creating tables and primary keys and sequences. Basically this type of column you can only assign to a primary key data type, and which needs to be unique and not null, and it's the same range, but every time you insert a row, it will by default add the next value. So the first row is 1, then is 2, then is 3, and so on and so on. But don't worry about it. Just so you know, this is the most common one is integer, and it's a whole number, so no digits, no decimal points, only whole number. Now, if you want decimal points, you have two types of data types. You have this decimal and numeric, and the other one, which is real, double precision, and float. And the difference between these two is the fact that the first two are very exact, and I will show you now, and these are inexact, are only exact on these decimal precisions. You will probably use this decimal and numeric. The difference between decimal and numeric is no difference, but there are some difference, but it doesn't matter to you. And you will probably use this, let's say, if you want specific calculations, like money, when you work with money and currency. But I show you here you can also have a specific data type, which is monetary. But decimal and numeric works just fine. If you work with money, you need accurate precision, you'll probably use these data types. But if you want just a column that will store decimal digits, but you don't care about the precision, you can use this, because these are more efficient in the terms of calculation, because in the terms of computation. Now, how would we example this. We can create some tables and we can assign some columns and assign these specific data types and trying to insert some rows, because now we know how to insert rows, but it's a bit tedious, and I will show you a shortcut to this. So I have here my Postgres. I'm going to query tool, open a query tool. So I'm going to show you something. You can select, besides with what we've learned so far, we select some rows from some tables. You can select something like this. Let me type select 5, and you can see here that behind the scenes Postgres has just created this pseudo table which has the row 5, and you can see here it has this integer data type, because Postgres automatically cast this number to an integer and figure this out. Now you can specifically cast this number to a specific data type by using this double dots, and type, let's say, small int. And you can see here that I specifically told Postgres, hey, I want this value to be a small int, and Postgres behind the scenes has automatically done this for me. Now if we go to our PowerPoint presentation, and you can see here I have this number, I can just copy it and type here. If you see here it works, but if I type the next one, if you see here I have this error, small int is out of range. That's because this data type, it has this specific range, and this number is basically too big for this place in memory to store it. And just wanted to show you can try the other examples, is basically the same. So if we type here integer, now it will work, but if we don't type, by default Postgres is going to assign it to integer. Now let me copy this. I will copy this. You see it is integer, but you see here if I add 1, Postgres will automatically cast to big int, because if I specifically told, hey, I want this to be integer, I will have an integer out of range. So Postgres is pretty smart to try to automatically do this conversion for you, but that is in only this select statement. When you will create specific columns, you need to specific tell Postgres, hey, I want this column to be a big int column or an integer column or a small int. Now if I type here serial, let me put big serial, you will see here I have this strange error, type big serial does not exist, but it exists, but you can't do it like this. You need to assign it to a column, but we will see this in a different video. Now let's talk about this decimal and this accurate precision and this imprecision. Now let me do something like this: 1.003 plus 1.004. And you can also do this, you can also do mathematical computation, and you can see here I have this result, and Postgres automatically by default casts it to numeric, which is basically the most standard one. And you can see here it's a precise calculation. Now let me put other 2 zeros, and here other 2 zeros, and you can see it works. Let me put another 0, and it works. Now let me cast this to a real number, and also this to a real number, and you can see here I have a different value. Why is that? Because this is imprecision, this is inexact, as you see here. Now let me add another 0 and another 0, and let me cast this to float. And you can see here Postgres has put double precision, and this is exact. Now let me do something else. Put 0 here and 0, and you can see here I have this strange number. This is basically some for scientific computation, mathematical computation, and I wanted to show you that this is inexact because it has 1, 2, 3, 4, 5, 6, 7 digits, and this is only for 6 decimal digit precision. For example, if I put 3 and 4, okay, let me put here, you can see here that now it gives an okay, I missed some 0. Okay, yeah, as you can see here, it's going pretty crazy because this is the data types which are real, double precision, and floats. It's basically the same thing. If I put double precision and here double precision, it's the same result. Now, what you will use most commonly is integer, big int, and numeric when you are talking about decimal digits or accurate computation, like, you know, working with money and stuff like this. And that's it about numeric or numbers category on the numeric data types in Postgres.